What's up, everybody? Welcome to another episode of the bstream machinery. In this video, we're going to cover the forkable and the forkdB implementation, which is sort of a crux in the platform. Again, this is low level. If you want to feel free to go to the next more high level videos. This is about the internals of the dfuse architecture. And I'm going to start right away with looking at the bstream repository here, where we see that there's a few handlers, a forkable notably, and in there lives the forkdB implementation. Now, the forkdB implementation is something you have also natively in Node.eos, but this one is out of band, and it allows us to support all the different forks in the same sort of process and navigate forks out, in and out. What that means is that I'm going to explain the situation of a forking situation, okay? So we receive the block 7, 8, and then we receive 9, 8, 9b. This is crap. Oh, magic. Okay. Now all of a sudden we receive 11b. So we don't know about that, but 11b says it's based on 10b. And we'll receive also at the same time 10b and 9b. Okay? This just happened. And this is now the longest chain. So what do? We need to undo this one, and that's what Node.eos does in memory. We need to undo this one, and then apply that one and that one, and so therefore we're now on the consensus truth, right? Everyone now agrees if this is the last thing you've seen, you should be there because it's the longest chain algorithm for consensus. But now, in our forkdB implementation, we have all of these, and this one is always with a pointer, right? Pointing to the previous one, and we have that in, let me show you here. The forkdB has all these links, the block ID and the previous block ID, and it has a map of all these objects, which is really a block ID in there. And you can add link there to add a new one when you receive a new block like that, or this one or that one, you add that link. It's also a way to do deduplication, because when you receive a block you've already seen, let's imagine you have two mind readers and you're receiving the same block. If you added it once, you don't need to add it twice. So forkdB also acts as a deduplicator. But you can also ask questions like segment. Give me the reversible segment up to block X. In this case, you're going to ask, okay, I'm at that block. What's the reversible segment? And the forkdB is also aware of the last irreversible block, and it's going to also understand, when this says, okay, my irreversible block is now 8. Then it's going to understand that this segment is now irreversible and can pipe out. So the forkable is going to do that. But the forkdB allows you to query, okay, what if this is now irreversible, and it queries that. So that's the abstraction of forkdB. And then there's the forkable. Forkable is a stream processor, right? You remember the interface we've shown yesterday, or in the previous video? So the forkable is itself let me show you here. Okay, so here I'm in forkable.go, and in there we have the forkable, which is a handler, and it receives as a parameter a sub-handler, and it is also itself a handler. Remember the interface we talked about yesterday? Well, it's going to process things, and what it will do is it's going to receive all the blocks on one end. Imagine it's receiving that from, relayers or mind readers. And it's going to recompute, okay, what's the longest chain? What do I need to do for my internal process to undo the things that need to be undone if I discover suddenly that, like for example, we're triggering a new longest chain. It queries the forkdB underneath. It's going to say, oh, this block brings me 11b. This triggers the longest chain. This was the longest previously. So I'm going to go and check, the undo and redo segments. If it triggers longest chain, I'm going to check for the undo redo segments, and I'm going to play them. If we asked to do the undos here, we're going to go and call the subhandler. Right? This is going to call the subhandler, CP handler process block, and it's going to give sufficient information like the step which we're in, if it's an undo step, a reference to the forkdB if you need that, the previous object, whatever, the step, and how many of those you're going to go through in the loop, so that the subhandler, as you'll see, will be able to take decision. Do I remove a thing from the database if it's an undo signal I'm receiving? If it's because it just passed the reversibility, forkable will send you also a copy of the block, a reference to the block with the signal saying step irreversible, so that oh, this just passed the reversibility, let me update this database, let me do that, let me revert, whatever, right? So the forkable transforms the incoming block, gives it a lot of knowledge and navigates things for you, sending again the blocks if they go through those life cycle events. So again, low-level building block, very useful, used throughout for deduplication, for forwarding, and it's very customizable. So that's how we do, like when you ask for irreversible only, we just configure the forkable, and all of a sudden the forkable does not send undo redo signal. No, it waits until it passes irreversible and will send you like 12 blocks at a time. Zoop, zoop. That is so you can have a fast do whatever you want, index or whatever downstream. So this is the last element, forkable, forkdB that we have in bstream. Basic element. I hope you enjoyed. I hope that it's clear. If you have any question, go to the Telegram channel, let us know, or here in the comments, and don't forget to start that repo. Hey, see you next time. Thanks for watching.